All right, so now we're gonna jump on over to Desmos and try to get this thing graphed. If we were in a classroom, we would be using graphing calculators, but until we are in a classroom again, we'll have to use Desmos. I think it works pretty good. Last year, when I was in the classroom, I taught both the calculator and Desmos. And there's a couple of things about Desmos that the kids seem to like better. So I just went to a regular um, Desmos screen. Um, I typed in the equation, well, and I didn't even less than, and you can put the or equal to just by as soon as you hit the less than symbol. Let me show you right here. I just hit the less than symbol, but if you follow it, now if you're using this keyboard down here, of course you can press that button, but you can also, if you follow it with or equal, you push the equal sign right after you do the less than or greater than, it puts the bar underneath it. Okay. So you put that in there and nothing happens. Even if you're like, well, I'm not sure anything happened or not, you search around and the little, warning symbol right there, tells you that nothing's happening. So the reason that nothing's happening is because since we're using T and M, it does not know which one goes on the x-axis, which one goes on the y-axis. So in order to actually get this to graph, you're going to have to do, you can solve this for M, which we did, and put it in slope intercept form. Then it will understand that the M goes in the y's place and the T goes in the X place. But if you'll just substitute the X's in place for the X's and the Y's in the place of the M's and the T's, it'll graph it for you. And less than or equal to 1360. Okay, now remember I moved my graph around, so the first time if you left it on the home, it would look like, oh my gosh, what is all this red? Well, move the graph out a little bit, okay? And you can see, and yeah, I've got something over there. I'll show you that in just a minute. You can see that this graph right here, this is what this graph looks like. And I did put this over here because I wanted just to compare it to the one that's in Springboard to see if we got, our graph right. Now, I don't like the fact that I've got grid lines on top of grid lines, so you'll have to overlook that. But does this graph look exactly like this one? We can see that this line right here does cross the y-axis at 34, just like that one did. It's shaded below, and this right here is 13.6, just like we calculated that one. So we've got some of this, we've got the same points, we've got the shading, but I hope that you see that this graph is not exactly like this one because it's got all of this stuff down here shaded. Okay, so what you can do on Desmos is you can, and it's also graphing this line down here and the line over here where we got negative values. If you trace that, it'll show you that we're at negative 1.65, and there are no negative values in this problem. This one's got a negative y value, and y's in the place. So a negative meals. How do you gonna have negative 5.1 meals? Negative numbers do not make sense in this context. So what we can do is tell Desmos, you know what? I don't want to graph all of this. I only want what Springboard graph. I only want to graph what's in quadrant 1. Okay, so what we do then, and I'm going to jump back to my whiteboard right here because I want to talk to you about this word right here, which is constraints. Constraints are going to be equations, or not necessarily equations because they don't contain equal signs, but mathematical statements using symbols that restrict my graph, okay? And so lot of you be thinking, oh, I know what to tell you to do about over here. We only want the quadrant 1. We don't want to see all of this stuff over here in quadrant 2, 3, and 4. You're absolutely right. So the constraints, if I were doing them verbally, would be to say, I want to graph this equation, and I didn't mean to move that, but I did. So graph it on Desmos. Okay. So what I meant to see was this inequality right here gets that line, but it causes all of this other, it goes beyond and it shades all of this. So I want to restrict this right here to the first quadrant. Okay. So a constraint right here, what a constraint is, it's a mathematical, good grief, I got a gnat flying around my head. M-A-T-H-E-M-A-T-I-C, a mathematical statement that restricts part of your graph. Parts of your graph. In other words, it cuts them off. It says we don't want to look at that part. So a verbal explanation of a constraint is a statement that says we don't want, or we could say we only want quadrant 1. Okay, so if we verbally say we only want quadrant 1, then the mathematical way to say that is, well, what does quadrant 1 have that quadrants 2, 3, and 4 don't have? So think about that for just a second. Pause the video, think about what quadrant 1 has, what kind of numbers are in quadrant 1, and what kind of numbers are in quadrant 2, 3, and 4. What does quadrants 2, 3, and 4 have that quadrant 1 does not have? So when we say we only want quadrant 1, what we are really saying, we only want positive numbers. And when I say we want positive numbers, we're going to be saying, well, for what? In this case, it was t and m, but we also converted it to x and y. So t, which is on the x-axis, okay, we will say that how do we say that we only want positive numbers? We say that t has to be greater than or equal to 0. Actually, it's not or equal to, because 0 is neither positive nor negative. So if we only want positive numbers, then we're going to say t is greater than 0. Now, can you buy 0 tickets? Yes, we can buy 0 tickets. If we buy 0 tickets, then we can eat 34 meals. So to say we only want positive numbers, this is how we say we only want positive numbers, but it's okay if we include 0. So this is positive numbers and 0. So this is talking about meals, and since we're going to be on Desmos, we need to change that to X. And then we've also got M, which is on the Y-axis. We only want a positive number of meals. It doesn't make sense to have negative meals. So our M needs to be positive. Now, I wouldn't make that much difference right here to me if you put the bar underneath it. But Springboard is saying no, don't put the bar underneath it. And the reason it's saying no is because we see that when you're actually on the t-axis, this value right here is 13.6. And so you would have 13.6 comma 0, and it's saying that this is not reasonable because it's a decimal. So it's saying don't include it's saying don't include the x-intercept, which has a 0 y value. Don't include that because it's not reasonable. So they're saying go up to 0, but don't include 0. So they didn't put the bar underneath this one. So we know that m is on the y-axis, so we'd say y is greater than 0. Now, let's go see what happens on Desmos when we do that. Now, you're going to have to listen, because if you don't listen, you're not going to know how to put these constraints in, okay? So we understand that the T and M didn't work, so I'm just going to delete that out. Here's the equation that did work, or you could solve it for y. You'd get the exact same equation. Here's how you do constraints. And remember, constraints are restrictions. You have to put them in the braces. And those braces, notice they're not down here. I don't see them down here anywhere. Maybe if you hit the ABC bar, get a keyboard right there, you get braces right here. Okay? You can just do shift and then your brackets. So anyway, you have to have the braces bar, and then you just type in the mathematical statement that we wrote. And we said we want x to be greater than or equal to 0. Uh-oh, I didn't put 0. And when I did that, let me lower this down. When I did that, it got rid of the negative x value. See, this is saying, hey, we only want positive x's. So no negative x's. That's what that says. And so it took all the negative x's away. But it still has negative y's down here. So go ahead and close the braces, open braces again, and say we only want positive y values. And now this graph right here on Desmos looks almost exactly like this. Well, it does look exactly like this one. Okay? So that's how you write constraints. Okay? I lost my timer, so I don't know how long I am on time, but I'm going to go ahead and stop it right now, even though we have, the next thing that we're going to look at are additional constraints, because this gave us constraints that put everything that we wanted in the first quadrant, and that's a very, very common constraint. So you definitely need to be familiar with those. But the other constraints that we're going to apply to this problem is going to be based on, the problem situation. So we'll pick that up in the next video.